So let's look at some simple examples of how to solve radical equations. So here's my first example. I don't like this color anymore, so I'm going to erase it. Let's get a darker color. There you go. I like this. So let's continue with the example that we had. So we had square root of x equals 2. Our instructions said to eliminate the radical, raise each side of the equation to a power equal to the index. Okay, well, what is the index here? What's the index? Do you see a number for the index here? I don't see a number. So when I don't see a number, then the index must be 2. If I don't see a number, then the index is 2. That means that this is a square root equation. So here my index equals 2. Right? Actually, I'm going to change this to a 3 so that there is no confusion. My index here is 2. So let's write it in red. Right? Actually, I'm going to rewrite this. Just make sure that. So because I know that my index is 2, I'm going to rewrite this. And so I'm supposed to raise both sides by the index. Well, what is my index? My index is 2. So I'm going to raise this side by 2 and this side by 2. So what happens is that this 2 basically cancels out this 2. The power cancels out the index. And that in turn cancels out the radical. So what am I left with? I'm left with x equals 3 squared, which means x is equals to 9, and I'm done. Now I can do a check. Is square root of 9 equal to 3? Yes. 3 squared is 9. So that means that my answer is correct. All right. So this is a one-step equation. Here we didn't have to manipulate anything. We just went through it and then we were able to find the solution. Now let's look at another example. Erase this right here. Let's draw a line right here. How about square root of x plus 1 equals, let's see, let's say 5. Okay, square root of x plus 1 equals 5. I need to get rid of the radical. So how do I get rid of the radical? Well, I have to ask myself, what's my index? Again, I don't see an index here, so my index must be 2. Now, is there anything with the radical on this side, or is the radical by itself? The radical is by itself. Right? So I'm going to go and I'm going to raise the radical by the index. So let's see, x plus 1 equals 5. I'm going to raise the radical by the index. Now what happens when I raise the radical by its index? The radical cancels out. No more radical. So now I can write this without the radical. X plus 1 equals 5. Am I done? I'm not done because I don't have the x by itself. So how do I get this x by itself? To get the x by itself, I need to subtract the 1 from both sides. So when I subtract the 1 from both sides, So when I subtract the 1 from both sides, then 1 goes away on this side, and what am I left with? I'm left with x equals 5 minus 1, which is 4. So that's my answer. Let's do a quick check. I'm going to take the x equals 4 and plug it into the original equation. X plus 1, 4 plus 1, oh, something is wrong. 5 squared is not 5, 5 squared is 25. So 25 minus 1 is not 4, 24. So the square root of 4 plus 1 equals 5. Is that correct? Well, what is 4 plus 1? 4 plus 1 is 5. So I get square root of something is not right here. 24, not 4. See again, it was 24. So square root of 24 plus 1 is square root of 25. Does it equal 5? Yes. Square root of 25 is 5. So 5 does equal 5. So that means that I did it right. Right. As you can see, we all make mistakes. Just go back and double check. If your answer does not make reasonable sense, then it's probably not correct. So always make reasonable sense. All right. Let's take a minute to take notes.